All right, your Java exam is coming up, and maybe you're feeling the heat. Don't sweat it. In the next, feeling totally confident to ace this thing.
So here's our game plan. We've got a clear path laid out, taking us from the biggest core ideas all the way to being completely exam ready. Okay, let's dive right in.
First up, let's get our heads around the single most important idea in all of Java, object-oriented programming. You'll see it called OOP everywhere.
The easiest way to think about this is with a car analogy. A class is like the master blueprint for a car. It's got all the details, engine size, color options, number of doors, but you can't actually drive a blueprint, right? An object is the actual car that rolls off the assembly line built from that blueprint. It's the real thing you can get in and drive.
And OOP has these two awesome superpowers. First, there's inheritance. It's basically like traits being passed down in a family. A child class can inherit all the features from a parent class, so you don't have to write the same code over and over. Then you've got this big word, polymorphism. All it really means is that one thing can exist in many different forms. Think about H2O. It can be solid ice, liquid water, or gas steam. Same substance, different forms. That's polymorphism in a nutshell.
Okay, so we've got the big picture ideas down. Now let's pop the hood and see what actually happens to your code after you hit run.
You write all this amazing code, but how does the computer, which only speaks in ones and zeros, actually understand it? Well, your code goes on a pretty cool journey. First, it goes into the compiler, which turns your human-readable source code into something called bytecode. Now here's the magic trick. This bytecode is universal. It's not for a Mac or a PC, it's for any machine. That's Java's famous write once, run anywhere promise. Then, the Java Virtual Machine, or JVM, which is like a mini computer inside your computer, uses its interpreter to translate that universal bytecode into the specific machine code your computer can execute.
So the most important takeaway here is the difference between these two. The compiler does its job all at once, before the program even starts. It translates everything into bytecode in one go. The interpreter, on the other hand, lives inside the JVM and does its work on the fly, translating the bytecode line by line while the program is running.
All right, let's get back to basics and look at the fundamental pieces you'll be using literally every time you sit down to write a Java program.
Every single program you write is made up of tokens. You can think of them as the atoms of your code, the absolute smallest individual pieces. And these tokens usually fall into two big categories of data types. You've got your primitive types, which are super simple. They hold the actual raw value, like the number 10 or the letter C. Then you have reference types. These are a little more clever. They don't hold the data itself, they hold the memory address, kind of like a signpost that points to where the real object is located in memory.
Now, when your program is doing a bunch of calculations, it doesn't just do them randomly. It follows a strict order, and a great way to remember it is ARL. First, it handles all the A for arithmetic, your plus, minus, multiply, divide. Next, it looks at R for relational operators, which are all about comparing things. Is this equal to that? Is this greater than that? And finally, it deals with L for logical operators like and or, which let you chain conditions together.
Okay, we've got the building blocks. Now for the fun part. Let's look at how we can give our code a brain so it can make decisions and repeat tasks.
For making decisions, you've got two main tools. An if-else is like navigating a maze. If this condition is true, turn left. If not, turn right. A switch, however, is more like a set of train tracks. It takes one value and sends the program directly to the matching track, or case. It's usually much cleaner and faster when you have a lot of specific options to check.
But there's a huge trap with switch. You have to remember the break keyword. If you forget it, your code will just keep on going down the tracks, executing the next case and the one after that. It's called fall through, and it's a recipe for some really strange bugs. So think of break as the stop signal at each station. Super important.
Now for loops. The main thing to know is when the loop checks its condition. You have entry-controlled loops, which check the condition before they even run once. If the condition is false from the start, the loop might never run at all. But then you have exit-controlled loops. These guys are guaranteed to run at least one time, because they run the code first and then check the condition at the end.
Let's move on to how the pros do it. We're going to look at how to structure your code so it's clean, easy to manage, and powerful.
When we talk about functions, they can be either pure or impure. A pure function is also called an accessor. It just looks at data. It doesn't change anything. It just returns a value.
An impure function, or a mutator, is the opposite. It actually goes in and alters the state of an object. It makes a change.
Now, this is a really key distinction. What's the difference between a constructor and a function? Well, a constructor is a special method that acts like a factory for your objects. It has to have the exact same name as the class, and it runs automatically whenever a new object is made. A regular function, on the other hand, just performs an action. It can have any name, and you have to specifically tell it to run.
Okay, a quick word of warning about arrays. Always remember, they have a fixed size. If you create an array with 10 slots, those slots are numbered 0 through 9. If you try to access slot number 10, it doesn't exist. You're stepping outside the boundary, and your program will crash. That's the danger zone.
So how do you prevent your program from crashing? With something called exception handling. It's like a safety circuit for your code. You put any risky code, like something that might access an array incorrectly, inside a try block. If an error or exception happens, the program doesn't just die. Instead, the catch block grabs the error and lets you handle it gracefully, allowing the rest of your program to continue running. It's a lifesaver.
We've covered a ton of ground, from the big ideas to the nitty-gritty details. We're at the final stage. You're almost there.
Here it is, your final checklist before the big day. Seriously, run through these points. Memorize the little details like byte sizes. Practice tracing loops on paper. Double-check your syntax. These are the areas where easy marks are often lost, so nailing these down can make a huge difference. You've put in the work, you understand the logic, and you are absolutely ready for this. It's time to trust yourself. Walk in there, execute with confidence, and show them what you know. You've got this.